Welcome
Okay,
everyone
so
to the Boltathon, the world's first Lightning Network conference and hackathon. Here we go. So this is Fabrice. How do you see your last name, Fabrice?
Drouin.
I cannot see
It's
that.
hard because it doesn't exist in English, so it's a hard sound to pronounce. But
So yeah, pardon my French, so I can't say that. So he is the Chief Technical Officer of Async, and he's going to be doing a live demo of the Lightning Network in action, and it's going to be pretty cool. And we'll be doing some Q&A throughout the session. And one last thing before he starts, I want to remind everyone that we are going to be doing project presentations of the hackathon on Sunday at 2 p.m. So that's going to be open. You all can listen in, and it's going to be free for people to attend. I'm going to send everyone links, and then yeah, and there's also going to be a little landing, a web page for people to vote on your favorite projects with Satoshis, and that'll help us like do the scoring for what the community thinks is like the best and coolest project. So hopefully you guys can attend and watch that as well. All right, Fabrice, I think we're good to go.
okay, and the presentation is supposed to be about 1 hour. Okay, because I think there's a question there.
Oh, so, yeah, 50 minutes if we can squeeze that in.
Okay, 50 minutes, that's fine. Yeah. I'll be looking at the clock.
Great.
Okay. So I'm going to share my screen. I'm going to start with just a few minutes of introduction to Lightning. I was told that everyone has a good understanding of what Lightning is about, so I'll just show a few slides. I'll come back to them during the session so that people understand, just a reminder of what Lightning is about. So this is basically how Lightning works. So you have a funding transaction that is published to the blockchain, and you have Alice and Bob have a commit transaction that spans this funding transaction, and Lightning is all about exchanges messages between Alice and Bob to change the way that funding transaction is split between Alice and Bob. So in this example, you see that Alice starts with a first commitment transaction that gives her 10 Bitcoins and nothing to Bob. And she sends 7 Bitcoins to Bob, and now they both have a commit transaction that sends 3 Bitcoins to Alice, 7 to Bob, and so on. And these updates do not touch the blockchain. So you can have as many of them as you want. They are limited to a dialogue between the channels that are involved in the payment. So it's not a global consensus system such as Bitcoin. So it can be instant. And you have slightly different properties when it comes to payments on Lightning. And for example, the fees you pay on Bitcoin, they are based on the size in bytes of your transactions. It's like the post office. You pay for the weight of what you're transporting. In Lightning, it's different, and the fees are based on the actual amounts that you are paying. So you can have micro payments with really small fees. That is very different in Bitcoin. So first funding transaction to open a channel, then you exchange messages to change the way the money is split. And when you're happy, you close the channel and publish a final closing transactions to the blockchain that's basically publishes the final state of the channel to the blockchain. In this case, it's 4 Bitcoins to Alice and 6 Bitcoins to Bob. Something that is really useful, sorry. Just going to show this one because I think it's going to be really useful in the end. Okay, this is the structure of the commit transactions that is used in Lightning. I'm showing it because I will come back to this as I demonstrate, but in your commitment transaction, you have one output for you, one for your peers, and one output for each pending payment. The structures of these outputs is different depending on if it's an incoming or outgoing payments. But basically, if you have 3 pending payments, you'll have 3 outputs in your commitment transaction. And what I want to show is, sorry?
Oh yeah, they're asking if there will be slides available after the talk because they really like your slides.
Okay, yeah, I guess I could probably share these slides. I've used them a few times, so it shouldn't be a problem. There are many of them. I'm just going to show a few of them because otherwise we wouldn't have time. But yes, I guess I can share the slides. I'll check with you after the presentation.
Awesome.
So what I wanted to show is that in Lightning, there's the concept of penalty transaction. Since you can have many valid commitment transaction, there's a trick that we use to make sure that only the last one can be safely published, and we call it revocation. So in every output in your commitment transaction, there's like a short circuit that says, if you know a secret key, then you can spend all the money in a commitment transaction. There are no timeouts, no hash pre-images, nothing. If you know a secret, you can spend the commitment transaction. And when you sign a new commitment transaction, you give to your peer the old secret. So basically you exchange signatures for secrets. What it means is, as all time, you have many different valid commitment transactions, but there's only one you can safely publish because your peers knows the secret keys they can use to span the outputs of all the other ones. So the only one that is safe to use is the one for which you did not publish. You did not send to your peers the revocation key. This is a very nice design, but there's a drawback. It makes backups of Lightning channels a bit more difficult than with the standard Bitcoin wallet. Because if you try to use an old backup, and if you don't remember basically that you have already sent the revocation secrets to your peer, if you try to use that backup, you may lose money. So in Lightning, there's something we call data loss protection that is implemented by all three implementations. When you reconnect to your peer, you exchange basically the index of the last commitment transaction. And if you see that you're behind, you can get your peer to publish their commitment transaction. And if you have enough data, hopefully you can get your money back, but you're not exposed to losing everything. So this, I will show it works in practice during the demo. So the only thing is you need to remember is Lightning channels are basically transactions that are not published. They're valid, but they're not published. And this is the structure of a commitment transaction. So what I'll do is I'll start a small network of Lightning nodes on RegTest. So RegTest is a regression testing mode for Bitcoin where you can mine locally. So it's very convenient for testing things. You don't have to wait for blocks to be mined like you have to on testnet. So what I'll do is I'll start 3 nodes locally, connect them, and show you what happens behind the scene when you use Lightning. So it's a bit slow, but it's coming up.
That's a cool design, though.
Yeah, we have a very good designer / web developer. He did all the work on the mobile wallet, and he does basically everything you can see is done by Dominic.
Nice, Dominic. I bet you he's on here. He says, yeah, I love the design. He's like shilling himself. Just kidding.
Okay, so what did I forget? Okay, 2 and a third one. Okay, so that's C, B in the middle. It's going to be A on the left. So I hope everyone can see it clearly. So we have 3 Lightning nodes. I'm going to connect them together, make a few payments, show what happens when you pay, show what happens when you close channels, and show what happens when your peer is not responsive and you have to close the channel, and what happens when somebody tries to cheat. So the first step is to connect these nodes. So I'm I'm going to connect A to B. I'm going to open channels of 100 millibitcoins. So what's going on now is those two nodes have exchanged messages together. A has a commitment transaction. A has asked B to sign it because otherwise it's not usable. And now A has signed commitment transaction that sends all the money back to its account, and it has published it. And A and B are just waiting for that transaction to be confirmed before the channel can actually be used. So I'm going to confirm it. I'll use, okay, I will use.
Okay, so this is on RegTest.
Yes, it's on RegTest. It's
Great.
something I've written the script for this. It's something you can do yourself. It's RegTest is not really that hard to set up, and it's very, very nice for learning how Bitcoin works and Lightning works. So if you've never used RegTest, it's really simple. It's part of every big Bitcoin node, and it's really nice for learning what's going on. So I've confirmed the funding transaction, and now you see that the channel has switched to normal. What it means is it can be used to exchange money between A and B, but it has not been published yet, because to publish a channel, you wait 6 extra confirmations. And then when we call it deeply buried, when the funding transaction has been deeply buried, it has been confirmed 9 times, then the channel will be announced to the whole network. But right now that channel is usable, and for example, B could receive money from A. So I'm gonna ask for like 10 millibitcoins. I create an invoice, a Lightning invoice, which I copy, and A can pay B and use that invoice.
So how many Satoshis is a millibitcoin?
One Bitcoin is 10 to the power 8 Satoshis. So 1 millibitcoin is 10 to the power 5 Satoshis. That's 100,000 Satoshis.
Cool.
So A has sent some money to B. So now I'm going to bury the transaction, confirm it 6 extra times, and that channel will become public. It's a choice. You can also choose to use private channel. I'll explain what it means in a few seconds.
So on mainnet, it probably takes about an hour for a channel to be fully complete.
So that kind of demo you can't really do on testnet, because it's just going to take too long. So what I've done is I've buried the funding transaction. So if these were actual nodes on testnet or mainnet, now they would show up on explorers like 1ML or others. There is something though that has been mentioned a few times, but it's still not well known. You can choose to have private channels, and there are many more channels than what you can see on explorers. And for example, terminal channels, that is channels that cannot be used to send or receive money, and channels are not published on explorers. You can't see them. For example, channels that are opened by mobile nodes are not seen on explorers. Channels that are used only to receive money, if you sell things on Lightning, but you just receive money, you never send money, your channels, there's no point in making them public because they will not relay money. So on explorers, you see, I think it's about 50,000 channels on mainnet now, but there are many more channels that you don't see. And the Lightning Network, as it is today, with a few dozen thousand channels, could very well serve lots of users, like potentially millions of users. You don't need to have 1 million public channels to serve 1 million users. That's something that is not always very well understood. So I'm going to connect that
one
node
question. Sorry.
Sorry.
One question people had is, are you working on autopilot to open channels for Eclair, I guess?
Not yet. We think it may be a bit too soon for autopilots. We're not saying it's not an interesting feature, but I think it's too soon now. So I still think it's better for now to have users select manually the nodes they want to connect to. There will probably be a need for autopilots, but for us, right now, manual selections of nodes is still slightly a better option. So I'm going to do the same here, connect the node in the middle to connect B to C. Again, for 100 millibitcoins. So it's the same. There's a funding transaction that has been published, and now both nodes are waiting for it to be confirmed. I'm going to confirm it 3 times. It will take just a few seconds.
So this setup here, is this something that comes if I download Eclair, or is this something that you custom built yourself?
No, it's something that's, I'm using Eclair out of the box. So it's something you can do yourself very easily. It's just not picking up.
Yeah, well, that's pretty cool that it kind of sets up like a dev environment on RegTest for, different nodes to connect to each other. It's very nice.
Yes, I think that you can do this with all 3 major implementations of Lightning, and I don't know why this one is not confirming. Okay, let me check quickly. It's a demo effect, something I've done 1,000 times, but
it's always like that with like demos and presentations. When you do it live, works perfect in practice, but when you do it live, something always.
So the only thing that works a bit differently on RegTest is since you publish nodes, blocks, and transactions very quickly, sometimes the watch mechanism is a bit slow, and running all 3 nodes and all 3 Bitcoin nodes on my machine is, I think, a bit taxing for it. Okay, sorry about this. Okay, so this channel has been confirmed now and can be used to exchange payments between B and C, which I'll show you right now. But right now, it cannot be used to send payments between A and C because it has not been announced yet. So it's as if it was a private channel. C can receive money from B, because B knows obviously that it has a channel with C, but A doesn't see it. It's not announced. So I'm going to have it broadcast in a few seconds. But suppose you have a private channel. How do you use it on the Lightning Network if it's not announced? There's something in the payment transaction, in the payment request that you generate when you receive a payment, where you can add optional fields, and one of these optional fields are what we call route hints. So if you are at the end of private channels that are not seen by anyone on the network and you want to receive money, you can add these channels to your payment request. So basically, it's a way of helping nodes on the network find you, and that's what I was saying a few minutes earlier. That's why. With a few dozen thousand public channels, Lightning could serve very well millions of users, because using route hints, you can have nodes that are not public, that are not announced, receive money from other nodes that are not aware that they even exist. You use the route hints in the payment request. So for example, if I try to get A to pay C, it will fail because A does not see C yet, so it can't pay it. If I generate enough blocks for that node to be, sorry, I made a mistake, it's not 3, it's 6. If I generate enough blocks for that node to be seen by everyone, then it can be used without routing hints. It will be announced to the network and can be used by anyone. No, 6 blocks. Whoops. Okay, so it's going to take just a few more seconds, just a few seconds, and I'm just waiting for there's a delay before you broadcast announcements, so that you don't flood the network with announcements. So it's not usually a problem on testnet because you have blocks every 10 minutes. When you do a demo and you have blocks every second, it's a bit annoying. But okay, now A can see 2 channels, so A can pay C. I'm going to try again. This time, if I generate a payment request, or 10 millisatoshis. Maybe I should mention what this does. So a Lightning payment request is a bit different from a Bitcoin payment request. Bitcoin payment request is static. It's an address, and you send money to the address, you send it to the blockchain, and no one has anything active to do. In Lightning, it's a bit different. So when you make a payment in Lightning, basically what you're doing is you are sending pre-images. So the pre-image of a payment hash is what is actually used in the script in Lightning to make it automatic to exchange money. So what C is doing now, it's generating a random number that's a pre-image. It's hashing that number, that's a payment hash, and it's including that payment hash in the payment request. I can add a description.
So one person is asking, how will future static addresses work in Lightning?
It's actually difficult to have static addresses. So because by definition, you want to create a new payment hash every time you get paid. So there are several options for for creating invoice-less payments. One of them is to overpay the fees. For example, suppose I want to send money to B, but B has not sent me a payment request. What I could do is send money to myself through B and overpay the fees that I'm giving B. So that's one way of paying someone without having an invoice. Another way is to basically send the pre-image with your with your payments. So basically, if you know the address of a Lightning node, you send it a message that says, "Okay, I want to give you to give you money." That's a pre-image, and just create a request, a payment request with that pre-image. But there's still a bit of friction because the way Lightning was designed was to create new random value every time you want to receive money. So static addresses is kind of difficult to get. So in that payment request, so I have a new random payment hash message that says this is 10 millibitcoins for shiny stuff. And now you can see that A can pay, we find a route and we pay C. There's something that you have to see though. It's A is not really paying C. A is paying B, and B is paying C. That's how payments work. That's very important because it is linked to one of the limitations of Lightning. If you want to pay someone, you need to find a path to that node, and you need to have enough balance in the channels that you're going to use to route payments to that node so that the payment can be made. So for example, in this case, the channels have been opened by A to B and B to C. So all the money is on the left side. All the money is on the A side, on the A to B channel, and on the B side, on the B to C channel. What it means is C can receive a lot of money, but A cannot really receive a lot of money. A is very limited in the way it can receive money. That's because channels are one-sided. It's something that's, there's a proposal for dual funding for the next version of the Lightning specs. So dual funding means when A opens a channel to B, A and B will both add inputs to the funding transaction, and there will be money on both sides. But it's not the way it works today. So when you create a channel, all the money is on your side to start with. So if you open a channel to me, you can send money to me. You can't receive money from me. So what everyone is doing now to enable receive on Lightning is to create services that will open back a channel to you. So there are many different options, but basically you pay a node to open the channel back to you and to give you inbound liquidity. This is something that will be much easier to do once we have dual funding. It's not the case now. So,
one question is, do you think developers should build apps with route hints to a single routing hub, or rotate which hub they use randomly?
If you're not using, if you are using private channels, then you need route hints if you want to be paid by regular public nodes. There's another option that I think people could be using now and nobody would be aware of it, is since you could really build a private network of private channels on Lightning, you would have to find a way to communicate the locations, the addresses and IDs of these nodes out of band. You could exchange messages with your friends to say, okay, this is my node, these are my channels, using whatever you want, but you could have hidden private Lightning networks that are completely invisible. They will leave, basically there would be a trace of them when you open the channels, when you close them, but everything would be completely hidden and stealthy. So that's I don't know if people are already doing that, but it's possible. Basically, if you want anyone to be able to use your services, and if you use private channels, then yes, you need routines. As for rotating the nodes, basically, if you want to receive money, you need to have a real channel that is connecting to your node. So you will be limited to the number of nodes that have opened a channel to you. So it would be a very limited rotation. I don't know if it depends what you're trying to avoid, but unless you have lots of incoming channels, basically you don't really have much of a choice when it comes to the last channels that can be used to find you.
Oh, another question is, can you use channels to mix coins?
Um, you can't. You could have nodes that have different channels with different coins. That's very possible. For example, one single node could have channels with on the Bitcoin blockchain and other channels on the Litecoin blockchain, for example. And if your chains use the same basic primitives, you could swap. Maybe that's the question. You could swap bitcoins for litecoins, for example. You could make atomic swaps between two different currencies. It's very simple. Basically, you just create payments that use the same payment hash on both chains. So this would be trustless. The one thing that is, I think, the hardest part when it comes to swapping between two different currencies is it's to set up an exchange rate, because what is trustless is the fact that there's a script that will give you money for a payment hash or for a pre-image. And if you use the same pre-image on two different coins, you can get a trustless swap. But how do you define how many Litecoins is one Bitcoin? That would be, I think, the setup problem for that. And since you may refuse to deliver the pre-image, there's an interesting side effect. It's like you're creating. So I don't know much about finance, but you're basically creating an optional contract. I want to swap X Litecoin for Y Bitcoins, but if I'm not really happy with the price, or if I think it's going to go up or down, I may refuse to just honor the contracts, and I may refuse to deliver the pre-image. There's a very interesting post on the Lightning mailing list about this. But yes, you could very well have nodes. There are provisions for this in the Lightning protocols. You could have nodes that have channels open on different blockchains.
Yeah, and I think it's like they call it the American call option on atomic swaps on the
Yes,
Lightning Network or something
yes,
like that.
that's what I was referring to.
Yeah, but actually with the development of HODL invoices, I feel like it'd be a lot more manageable, right? Or not so
There's
much.
still the fact you can still decide to not send the pre-image back.
That's true. Actually, one of our speakers is going to actually talk about that, I think. So yeah, I've still lots to learn.
Okay, so I've made a few payments. What I will demonstrate now is what happens when you close channels, the good way, the bad way, and the ugly way. So the good way to close the channel is to negotiate a closing fee between the two Ps. So for this, both nodes need to be online. So if I want to close, for example, the channel between A and B, this one, what is actually happening is A and B are exchanges messages that say, okay, I think that the on-chain fee we need to pay for that closing transaction is X. And when they agree on the on-chain closing fee, they publish a transaction that sends them back the money they had to their wallet. And there are no delays. So A and B on a mutual close get their money back instantly. So you can see that, which one is it? you can see that transaction has been published on the blockchain. It's this one is B's and A's is here. So A has received a Bitcoin transaction. It's not confirmed yet. That returns 89 millisatoshis, and B has received a transaction that returns.
Hey, Fabrice, I have another question from the audience.
Yes.
Does a node with many open channels that handles a lot of traffic tend to have balanced channels or channels that are maxed out?
Sorry, can you repeat the question?
Yeah, so a node with a lot of channels, open channels,
Yes.
and they handle a ton of activity, do they tend to have more balanced channels, or are those channels typically maxed out, like they run out of liquidity in one direction or another?
Okay, so if you don't do anything, you'll run out of liquidity because payments are not symmetric. Basically, the money flows from end users to merchants. So if you don't do anything, your channels will get closed. So what we do, we have a few really large channels. We need to watch them. And for example, if there's someone that receives a lot of payments, we try to have not one, but maybe 2 or 3 channels to them. And when we see that they are getting empty on our side, we open a new one. But if you don't do anything, then your channels will not get balanced because the flow of payments is not balanced.
Yeah, so I guess it's not even so much like how many channels you have or even the activity. It's just where, like, which direction is the flow coming from and going out to.
Yes. So if you're connected to someone who sells things on the internet, they will never send money. They will just receive money. So the channels you have to them will get depleted on your side very quickly, which is a problem because if your balance goes below a given amount, you won't be able to send money to them. So that channel becomes unusable. So now I'm going to confirm that closing transaction. What you can see is that the channel is closed now. So the money has been confirmed on chain. There's nothing left to do. And basically that the channel is gone now. All the money is back on chain. So this is what happens. That's the good case when both nodes are online and you negotiate a closing fee. But sometimes, and it happens a lot on testnet because there's nothing at stake. It still happens on mainnet too. What do you do if, for example, C goes away? Your B, you have a channel with quite a lot of money in it, and the node it's open to is gone. It's offline. It's not responding anymore. You have a problem because you have locked money in a channel that is useless. So you can decide to force close it, which means you publish your current commitment transaction, which is what I'm going to do now. But now there's something that is not symmetrical, and that's a bit of a problem. Your output in your commitment transaction has a delay. That delay is used to give the other guy enough time to publish the penalty transaction if you try to cheat. The remote output doesn't have that delay. It's not symmetric. And that's one of the limitations of Lightning currently that is going to be fixed very soon in Lightning, and that is very different in the way L2 works. But it has several implications. The first is you don't want to force close your channels. You want to as much as you can, you want to get the other guy to force close channels because that's where you're getting money back straight away. So there's an incentive a bit perverse to wait a bit when there's an error and wait a few seconds before you publish your closing instruction in the hope that the other guy is going to do the same and you won't have to wait for your money. But sometimes you can't avoid it. So if your peer is gone, completely gone, you don't have a choice. After a while, you have to close your channel because it's locked monetary useless, then you need to wait. So in that case, B has to wait about 720 blocks, which is about a bit less than 5 days before they can get the money back. That delay is what makes Lightning trustless. That delay can be used if you cheat to punish you. It can't be instant, otherwise there's no way to enforce the penalty transaction mechanism.
Yeah, like, kind of along that same line, someone from the audience is asking, what if there isn't actually enough funds in the channel for the closing on-chain settlement fee?
That's a very good question. If you have if you have tiny channels because the fees were really low when you opened them, and the fees are getting so high that you can't really pay on-chain fees, you have no incentive to close it. It's better to wait. Even if your peer is gone, if you see that the on-chain fees are going to be so high that you're not going to get anything out of that channel, you might as well leave it open and wait until the fees get lower.
Got it.
So,
also, I just wanted to give you some timing. It's we have about 8 more minutes before the end of the talk.
Okay, so I'll try to do that quickly, and I'm going to show you what happens when you cheat. Okay. Okay, so I've published enough blocks. The channel is gone now. The money has been claimed on chain, and that's the bad case. That's what happens when your peer is gone and you have to force close. It's also what happens when there's an error. There are errors in the protocol that result in you getting your channels closed. It's pretty annoying, but when it happens to you, but it can happen. So I'm going to start again, and I'm going to show you quickly what happens when you try to cheat, because
we have one more quick question. So is it typical
yes.
that a node uses the same single public key for channel creation, or does a node rotate keys?
It's better if you rotate keys, because otherwise the key you send the money to, the address you send the money to, depends upon your peers. You are creating a multi-sig transaction that sends money to your funding pub key and the other guy's funding pub key. So even if you don't rotate your key, the address will be different. But usually it's bad practice to reuse keys. So if possible, you should use different funding pub keys every time you create a new channel.
The second question is, does BIP32HT wallets get used for the Lightning Network?
Yes. For example, Eclair can be used on desktop with BEC32 addresses. It's not the case on mobile yet because support for BEC32 is not universal yet. So if all you have are BEC32 addresses, some services will not work with you. But you need SegWit to work properly with Lightning, and BEC32 is an option that's what I'm using now on the demo. I've set up Eclair in BEC32 mode, so the on-chain addresses I'm using are BEC32. So I'm just going to do the same. As before, 100 millibitcoins. And it's a typo, sorry. Confirm it. And now it's usable. So all the money is on Alice's side. Bob has nothing. So let's make a few payments. So I'm sending 20 millibitcoins from A to B. And I'm going to do it again. Now, before I do that, I'm going to do something. So now A has 80 millibitcoins and B has 20 millibitcoins. So now, unfortunately, I'm going to use the command line. I won't do that very often, but I'm going to look at the state of our node A and see what's inside. What's my, okay, 9,000. Okay, in my channel, there's a commitment transaction, this one. And if I try to look what's inside, I see that it spans a multi-sig. You can see that you have two signatures in a witness, and it says it sends money to, that's B's output, the 20 millibitcoins, and that's my output. And you can see that this one is a pay to WKH, which means it's going to be usable straight away. And this one is a pay to script. The script is says you send money to me, but if B knows the verification key, they can spend the output. So this is my commitment transaction. I'm going to make one more payment between A and B. And so now you see that I had 80 millibitcoins. Now I just have 50 millibitcoins. So I may decide, okay, this is not good. I had more money before. Maybe I could get away with publishing my commitment transaction. So let's do that. Again, the script and the scenario for the demo is something that I will also make public. So if you want to do the same with Eclair, or I guess it could be even doable with other implementations, you see the same. So what happens if I publish the previous commitment transaction that I had that gave me more money? So now it's published. You can see that the channel is getting closed. It's closed because there is an on-chain transaction that is pending the funding transaction. But you can also see that B has detected. You can see it there. B has detected that an old state has been published. And so it has published a penalty transaction that will steal A's output.
That's pretty cool. It's cool to see it from the command line terminal with all the logs too. All right, Fabrice. Well, thank you so much for your time. Unfortunately, we're out. And yeah, where can people find you?
They can find us on GitHub on the async repo, where you have the code for Eclair, the mobile node, and everything. And we are also pretty active on GitHub. That's where we do support for Eclair. If you have questions, open questions about what we do, the best place to contact us is GitHub. The coordinates are easy to find on GitHub or on async.co.
All right, thanks, Fabrice. People in the chat are very appreciative of your time. They say it was a great job. Okay, I'll talk to you guys later. Bye. The next session is Trey, and hopefully we'll see you guys there.
Okay, thank you very much. Thanks.